Welcome to the Cosmic Savannah with Dr. Jacinta Delhaize
and Dr. Daniel Kahnemer. Each episode, we'll be giving you a behind-the-scenes look at world-class astronomy and astrophysics happening under African skies.
Let us introduce you to the people involved, the technology we use, the exciting work we do, and the fascinating discoveries we make.
Sit back and relax as we take you on a safari through the skies. All right, welcome to episode 59 and to this very special episode to be released on, the 5th of December.
Yes, this is a very special inter-season bonus because there's something very special happening today, isn't there, Dan?
Yes, it's my birthday.
Yes, it is your birthday, but I was actually referring to something else. Today is the construction commencement ceremony of the SKA telescope. And so for those who listen to our podcast regularly, you'll know what the SKA is. It is the largest radio astronomy mega science project in the world, in the history of the world, and it is going to transform our understanding of the universe. It's been in the planning for more than 3 decades, and construction of it is finally starting.
Yes, so the SKA is getting built by something called the SKAO, which is the Square Kilometre Array Observatory, which is an intergovernmental organization. It's only the second IGO in astronomy after ESO, the European Southern Observatory. And the SKAO will build and operate the 2 largest and most sensitive radio telescopes in the world. It's a global partnership. There are 15 countries involved, and a number of African countries too as part of the African VLBI network. The SKAO is headquartered in Manchester in the UK, and the telescopes will be based in South Africa and in Australia.
Yeah, exactly. So there's 2 host countries, which is quite unique for one observatory. They are split into 2 types of telescopes. One is called the SKA Low. So this is detecting the lower frequency radio waves. And this is going to be built in Australia, most centrally in a region called the Murchison in Western Australia, which is where I am from and where I actually am right now. And the other is going to be called the SKA Mid. So this detects mid-frequency radio waves. And this will mostly be built in South Africa in a region called the Karoo. And at both of these places, there are already what we call precursor telescopes. So these are only about 1 to 3% the size of what the SKA will eventually be, but they in themselves are already among the world's most powerful radio telescopes. The precursor in South Africa is called Meerkat, and that wins the prize for naming. The 2 in Australia are not as interestingly named, but they are as interesting telescopes. They are called ASCAP, the Australian SKA Pathfinder, and the MWA, the Murchison Wide Field Array. So they already exist, and now the SKA, which, as I said, has been in preparation for more than 3 decades, it's finally got the approval for construction, so we're going ahead.
Yeah, so contracts have been signed and people are being employed, jobs are being awarded, and everything is kind of underway now.
Yeah, exactly. And in Western Australia, where I am at the moment, the Indigenous Land Use Agreement has now been signed. So there has been an Indigenous name given to what we call the CSIRO Murchison Radio Astronomy Observatory, which is where the precursor telescopes are currently built and where the SKA will start to be built. So it's now called the Inyarimanha Ilgari Bundara, which means sharing the sky and stars, which I think is a really lovely name because that is essentially what the SKA is. It is, as you said, intergovernmental. It involves 15 countries and plus more countries in Africa, and we're all under a shared sky. We're all seeing the same sky and we're all working together to try and understand the stars and the universe, which I think is awesome.
Yeah, it's brilliant. It's a wonderful name. And I think that, more than the 15 countries and the African countries, the SKA is going to transform our understanding of the sky and of the universe for all mankind.
Yeah, absolutely revolutionise it.
Today we're very fortunate to be joined by Dr. Catherine Cesarsky, who is the chair of the SKAO Council, and she has had an incredible career, which she'll be talking to us about, as well as the SKA. She has been the head of the European Southern Observatory, which we mentioned already, the head of the Center for Atomic Energy in France, and has spearheaded the design and construction and deployment of several of the world's most powerful and biggest telescopes over the last 30 years at various different wavelengths, the infrared. She was part of the Infrared Space Observatory. She was part of the construction of the Very Large Telescope, the Extremely Large Telescope, which is still under construction, and the Atacama Large Millimeter Array, ALMA. And now she's involved with the SKAO.
Yeah, I mean, I don't think it's possible to have a more experienced and qualified person in charge. And she's basically everyone's boss. We're very lucky that it's Dr. Catherine Cesarsky. And so without further ado, let's hear from Catherine. Just a note to say that unfortunately we had a problem with Catherine's audio, so the quality does kind of go in and out. Apologies for that, but I hope you'll manage to listen to the whole thing anyway, because Catherine has some really amazing stories to tell. So enjoy. With us today for this extremely special episode, we are very fortunate to have with us Dr. Catherine Cesarsky, who is the chair of the SKAO Council. Welcome, Catherine.
Welcome to the Cosmic Savannah. Thanks so much for joining us. Very exciting times. The SKA finally going ahead with construction. But before we get into that, do you mind just telling us a little bit about yourself and your science background?
Yes, I am an astrophysicist. It's a word that I like very much. I think it defines me more than my nationality and many other aspects of my life. A passionate astrophysicist. I'm French-born, but my parents moved to Argentina when I was a little girl. So I was raised in Argentina, and I have a university degree in physics from the Buenos Aires University. And I was lucky enough to obtain a scholarship to go and do a PhD at Harvard in the United States. So I did a PhD on cosmic rays, propagation of cosmic rays, a completely theoretical thesis, which was a mixture of plasma and astrophysics. And I was also very fortunate in obtaining a postdoc in what was then, between Harvard and Caltech. These were the top places. Well, there's Princeton also, and I worked a lot in Princeton. I was Director General of ESO, the European Southern Observatory, between 1999 and 2007. So at ESO, not only did we finish the VLT and its instruments, but we wanted to do an extremely large, we already had a very large telescope, so we wanted to do an extremely large telescope, which ESO is now constructing with a diameter of 39 meters. And also I started ESO on a path to construct very large array of radio telescopes, and this is called ALMA. So ALMA has 66 antennas, and is at the moment the largest array of radio telescopes in the world. Research-wise, I should say, so the first period of my life I did theoretical work on cosmic rays, propagation, and then on acceleration mechanisms, and in general plasma astrophysics, so magnetic fields were very important for me. I also was working in cosmic rays, gamma rays, X-rays, and then I became interested in galaxy evolution mostly. And then one day I got a phone call from the vice president of the board of the SKA organization, who asked me whether I would be interested in becoming the chair of the board. So I was very interested in SKA because, and I'm sure we'll discuss this later, I think it has an absolutely outstanding scientific case, and I'm a scientist first, So there are so many questions in astronomy that SKA is going to be able to answer. And it's extremely complementary to ALMA or the VLT or the ELT or the James Webb Space Telescope. We need all of those to understand what's going on in the universe. So I was very interested in getting involved in SKA, and I accepted that as well, and became chair of the board of SKA in October 2017. And in a few years, we managed to go to the next stage, which is the SKA Observatory, where we are now. So at the moment, I'm chair of the council of SKA.
You've had this incredible career, and you've been at the forefront of some of the biggest telescopes and biggest telescope projects that have come in the last few decades. Now you're at the chair of the SKA Council. What excites you about the SKA? This is the new surprise. And what are you really looking forward to? And what is it about the SKA that drew you in?
What excites me about the SKA is the fantastic science that it will be possible to do with it. SKA can address practically every exciting subject in contemporary astrophysics. Because, as you know, light comes in many kinds, and in the universe, many objects emit at various wavelengths. But almost every object emits some radio waves. So for almost every study, you can complete it with radio waves. And then there are many things that you can do only with radio waves. And in particular, the most abundant element in the universe is hydrogen. And therefore, it's very important to understand what hydrogen is doing, not inside the stars, but in between the stars. In between the stars, there is gas, and this gas is very important because that's where new stars are going to be formed. And in general, it will have a very important role in the way galaxies function. And you want to understand the story of this hydrogen. And the hydrogen can be in many forms, but the most common form is atomic hydrogen. So it's not ionized and it's not forming molecules like in the air. And this atomic hydrogen emits a very faint line at 21 centimeters that fall in the radio range. So if you want to observe it, you need to work in radio. And as the universe is expanding, if we want to look at what hydrogen was doing at earlier times, we will have to observe not at 21 centimeters, but because of the expansion of the universe, the emission gets pushed to longer and longer wavelengths. And so we need to observe also in longer wavelengths, which means low frequencies. And like this, we'll be able to say not only what hydrogen is doing now, but what we was doing throughout the history of the universe. So that's a unique thing that can be done only in the radio.
So you have this telescope which is going to be able to detect magnetic fields, hydrogen, gas, and all of these other things from the very early cosmic times, when the universe was a lot younger than it is now. Why do we need a telescope like the SKA to do it? What's special about the SKA that helps us do it? What is the SKA exactly?
SKA is a radio telescope, or actually two radio telescopes, because it covers a very large range of frequencies. And so this has been divided in two ranges, which will be observed with completely different sort of radio telescopes. So the higher frequencies and the lower frequencies. And in both cases, techniques will be used which are quite similar to techniques already used in much smaller radio telescopes. But of course, we'll go to the most modern, the ultimate techniques that we know to do this kind of work. And also we go to models that can be cheaper and cheaper to be able to do many of them. Because what is so special about SKA is the size. The most important thing is the size. Because the bigger a telescope is, it's like a bucket. If you want to catch the water that is falling from the sky, if you have a small bucket, you catch a little bit of water. So for instance, you are looking at a star, it sends light everywhere. And if you have a small telescope, you catch a little bit of the light. If you want to observe something that is very faint, you need to put a very big bucket to catch the little bit of light that it is sending us. So that's what SKA is going to do. It is the big bucket. And therefore, it will be able to have sensitivities much higher than previous telescopes. It has another very interesting aspect, which is that it will be at any time, it will be able to see a much larger portion of the sky than the previous telescopes. As a result, when you will use SKA, you can do surveys. You want to measure everything that's going here in the region of the sky, and you will be able to do that much, much faster, really, than previous radio telescopes. So you will get enormous amounts of data, and more in astronomy these days, we are advancing important statistical studies on types of objects. And this will be possible with SKA. And address, of course, the big mysteries in astronomy these days. What is dark matter? What is dark energy? That are much more important in the universe than the 5% of the matter and energy of the universe, which is in the form of matter like the matter we are made of. And this, of course, is a very fundamental problem in astronomy, which is going to be addressed in several ways in the optical in the future from ground and from space. But you can use similar methods and do studies in radio. And so SKA will add enormously to this kind of subjects. The discovery of dark matter, perhaps in galaxies, has been made by measuring in our own galaxy, even and in nearby galaxies, the fact that gas is turning around the center of the galaxy much faster than one would expect from the simple laws, the Kepler laws, if the galaxy mass had been only the one in the matter that we can detect. And so that led to the idea that there was dark matter exerting gravitational forces on matter, but that we couldn't measure in any other way. This continues to be a very important way of measuring the amount of dark matter. And SKA will be able to do this kind of study on galaxies further and further away and discover how much dark matter they have. And there are just millions of examples like that. SKA is going to do so much. Just to say, in dark matter and dark energy, it's going to be very important.
It's really going to change the landscape of astronomy. We spoke with the Director General, Phil Diamond, last year when the SKA received the green light to go ahead with construction. And now we're at the point where there's, feet on the ground and real construction is happening. The SKA project has been planned and developed over many, many years, decades. What does it feel like now to see one of these projects come to fruition and actually begin?
Well, of course, it's a great satisfaction, in particular, to the many, many people that have been working on it in the early stages, which is not my case. As I told you, I only joined the project in 2017. So for me, it was not a long wait. While other people spent decades getting SKA together, I was,
busy launching all of these other telescopes.
ALMA, DLT, and it's interesting because at some point with Phil and others, we organized a meeting on the future large facilities. And so he was pushing SKA, I was pushing ELT, and we had the JWST, etc. We have a little book, proceedings of that meeting a few years ago. But so for me, SKA is what I was not doing. So I haven't been waiting so much for it. I was very lucky. I started in 2017 and the decisions were taken very, very few years later. But of course, I'm very, very happy that it's happening and that I'm in the action because, as you can see, I like action.
So speaking of the action stages, what's happening now? I mean, this is a monumental occasion where we're starting construction. So what are the stages happening now?
There are several things in parallel. The first thing you have to do is infrastructure. You need roads, buildings, and that sort of thing. And first of all, before that, complete the access to the site to be able to go. And so there's some political steps to be done, and I would say governmental within each of the host countries to have access to the lands and be able to bring telescopes there. And of course, the other thing is people, because to construct you need people. Because in parallel, as I was saying, the second thing is to start making contracts. At the moment, already 200 million euros committed in contracts in the short time that we've had since construction was decided. And many more, of course, in preparation. The present contracts are more in preparing infrastructure. Then you could think that with the COVID, it would not be possible to do work. But I'm amazed to see how well the project has been able to advance since construction was decided in each of these aspects, and in particular in hiring people. So they have hired 40 people, for instance, in the last year, which is a lot because, of course, each one is handpicked. Mm-hmm. And also directors have been selected and put in place for the part in South Africa and for the part in Australia. Directors and director of constructions. It's like two people. One is the future director of the observatory and the other is overseeing the construction. So in both places, it's 4 very important people have been put in place. and many other aspects of this kind. And of course, in parallel, work on the prototype telescopes in both frequency ranges.
So we've chatted a lot about MeerKAT and ASCAP, and then also the EMWA in Australia, the precursor telescopes to the SKA, in particular being based in South Africa and Africa. We've talked a lot about the benefits that MeerKAT as an investment in the country have brought to the people of South Africa, and then just the incredible development of astronomy students and astronomy capacity. The number of radio astronomers we now have and technical staff operating MeerKAT engineers, it's really exploded. So we've seen a lot of these benefits already, and SKA is another step. Can you just talk a little bit about what future benefits you see and how is it going to change for South Africa and for Australia?
There will be benefits of many kinds. One thing that I see is not said very much. Countries sometimes or often like to be hosts for facilities of this kind because on the long term, it always reports all kinds of economic benefits. Because when you have a facility like this there, it means that many countries in the world are pouring money and the money is going to be spent in your country. And a large part of it will end up in your country. So this is, I realize it's not said very much in the case of SKA. So this is why I wanted to say it today. So it's not just the benefits during construction, but after that, for decades, SKA will work. And for decades, this will make all the other countries invest money that will be spent in South Africa and Australia. So that's already one benefit, in my opinion, not mentioned enough, which while in other cases, most countries admit that this is why they want to be host. So, on the shorter run, of course, in the time of construction, SKA will continue what indeed MeerKAT has been doing extremely well, which is, on the one hand, attract young people in the country towards astronomy, perhaps, but I would say science and technique in general. And this is useful not just obviously for astronomy or for SKA, but it's useful for the country, training young people to later work in many, many different avenues using very particular skills that can be learned through astronomy. It's also a bit of astronomy for development. SKA is doing it at a very, very high level. And as you know, they are giving scholarships, a large number of scholarships, and many of them to Africans, and not just from South Africa. At least 30% have to be from other African countries, and they are indeed preparing young people for that. So that's very interesting. At the same time, of course, you are developing techniques there. We haven't mentioned yet something extremely important about SKA, which is the data reduction. The way SKA will observe is completely different from what were used with the other observatories. You know, another observatory, you point your telescope, say, even James Webb Space Telescope, which is being such a success at the moment. You point it towards the source you want to observe, you put the type of observation you want to do, you get the data, and actually in the case of James Webb, everything is ready very quickly, you get a result. Well, this is not at all what is going to happen with SKA. In the case of SKA, in particular, I would say for the Australian part, but it's also true for the South African part, you have a large number of antennas on the ground, separated by smaller or larger distances. If you want to have a high resolution on the sky, you need large distances to see small details. And this is why they will extend over several kilometers. And to do something out of this data, you will have to use computers. The total amount of information that would arrive is just too high to even be gathered completely. So with the computers, you have to decide from everything that it's possible to take out of what this radio telescope is seeing, the part you really want to see. So instead of pointing the telescope, which in the case of the part in South Africa, in Australia, you cannot even point it. It's just antennas that are lying on the ground. You, with your computer, decide which antennas from which part you want to use in which way, and you can make images, actually even very detailed images, just through this very complicated computer work. And it could be that later completely different things will be obtained from the same set of data. And this will take, in my opinion, years to be refined and refined and refined. And it will have to use the most sophisticated ways of dealing with data of almost anything that is being done in the world at the moment. So the people who will be working on this, again, will acquire skills that will be useful in so many aspects of life, because more and more we are working in a world where huge amounts of data are obtained, and you have to see how to deal with them. So this will, again, put the two host countries and also the third, of course, the UK, in a very good position with respect to this kind of skills. But obviously not only those three, but all the other countries involved in SKA.
Wow. That's incredible.
We talk about astronomy over the years and how there's been these developments which have come out of astronomy and GPS and things which astronomy has assisted in developing, CCDs and cameras. And I guess for SKA, it's going to be this. It's going to be data processing. It may not be how to build a telescope better. It's going to be how to deal with huge amounts of data. And that's something which everyone's going to deal with at some point over the next 50 years. And we're once again at the forefront. So I suppose...
You're welcome, world. So, Catherine, I mean, I'm basically speechless with all of this incredible, like my mind is just blown. But you said something really profound at the start. You said that you call yourself an astrophysicist first and foremost, rather than a French person or an Argentinian person or something. I love that. And do you think that astronomy, and in particular the SKA, is something that kind of brings countries together and unifies us all in the world in a time when nations can be quite divided? This is something that brings us together with international diplomacy and to achieve a common goal as humanity. Is that something that you see as a benefit of the SKA?
Yes, very much so. I very much see SKA as favoring dialogue among countries completely above any kind of political questions or problems. And here you have a set of people, the astronomers, wanting to understand the sky. And of course, we have only one sky. We share the sky with the rest of the world. So altogether, we want to know what's going on there. But also from every other aspect, like the other benefits, of course, the advances in techniques in dealing with data and all those aspects are shared. To share this between countries independently of whatever else is going in the world is, to me, very, very important.
Yeah, absolutely. And it's just going to be so exciting to see what we achieve with the SKA, both scientifically, technologically, computationally, socioeconomically, diplomatically. It's all exciting. Catherine, I know you've had a long and illustrious career. You mentioned that you were the director of ESO, but I know you've also been director of a whole bunch of other huge institutes in France. You must have so many stories throughout your career, sort of starting from what got you interested in astronomy in the first place when you were an undergrad in Argentina, all the way until now. We'd love to hear some more stories.
So I did my master's thesis in Argentina already in astrophysics. When I was in my third year, I was very fortunate that an astrophysicist joined the professors there, and it became possible to study astrophysics there. In parallel, I was working on the construction of the first and almost only Argentinian radio telescope, because the Argentinian professor we had was very clever, and he had managed to obtain a gift from the Carnegie Foundation, which was an antenna of 30 meters, not very small, a radio telescope antenna in boxes, and everything was brought back to Argentina. And then we, the students and then young postgraduates, helped put it together and doing all the electronics part and all this. So in a way, that's how I started my career, although I was a theorist in my early stages. So in parallel, I was doing theoretical work and actually models of stars with very, very primitive computers. Anyway, this allowed me to meet some important people all over the world who came to inaugurate the radio telescope. And I was lucky enough to obtain a scholarship to go and do a PhD at Harvard in the United States. So I did a PhD on cosmic rays, propagation of cosmic rays, a completely theoretical thesis, which was a mixture of plasma and astrophysics. And I was also very fortunate in obtaining a postdoc at Caltech. And there I worked with really very top-level theorists, like in particular Peter Goldreich. And after that, actually, I wished to go back to Argentina, but the political situation was such that decided not to. And instead, the French offered me jobs, and I went to France. I say in plural because I was married to an astrophysicist, and we both had this career. We both did Harvard PhDs, we both had Caltech postdocs, and we both went to France. And in France, I joined the Commission for Atomic Energy, which is not only responsible for nuclear energy, which of course is very important in France, but has many other subjects, and in particular, basic research. And there was a group of astrophysicists working mostly on space experiments. So I initiated in this group a theory group, and for about 10 years continued doing theory. We were about 10 people and worked on several subjects. And I must say I was lucky enough that I made myself a name, I would say, in that. But as I said, I was immersed in space experiments, and I needed for my research data that could only be obtained in the infrared. And so I became very interested in an infrared satellite that could be done in Europe. So I lobbied for it and helped have a decision to have this infrared space observatory accepted by the European Space Agency, and also agitated to get the European astronomers ready to construct the instruments, and got so immersed in it that I ended up being the principal investigator of one of the instruments, which was the camera. So this was the first space infrared camera. It's interesting to say it today because the range of frequencies, the part of the spectrum that it was observing in is about the same as the James Webb Space Telescope. So,
oh, cool.
With my little camera, which was, something really, I don't remember the size, they say 30 centimeters, 40 centimeters, really small. And the first arrays, extremely small arrays, gathering the light and making images. I would say I made the first space images in this infrared range. And, we were the first to be able to see in this frequency range that the galaxy had a shape, was spiral. Before that, an external galaxy was just a blob. All the galaxies were blobs, and we were the first ones to be able to show what they were like. And we made some important discoveries with it. And to be able to do this in a group that had been until now was working on high energy, as I had before, I needed to take hold of the strengths of the observatory, of the group, in Saclay, where I was working. And actually, I was made head of the astrophysics group, about 150 people. So that set me on a road of taking more and more responsibilities in running things, and also getting involved in constructing equipment at a higher level, I would say, than the radio telescope in Argentina. And by 1985, I was made head of the astrophysics department. And in 1993, decided to stop doing that, to concentrate on the science I wanted to do with ISO, the Satellite Infrared Space Observatory, which in the end was launched in 1995. And so for a year, I concentrated on my proposals. But then, to my surprise, I had a life full of surprises, I must say. The Atomic Energy Commission offered me to become the director of all the basic research in physics and chemistry in CEA. So this time, this was really a lot of people all over France, not just at Saclay, close to Paris, where I was working. It was 1,800 people in very varied subjects. Now, I have huge interest in general in physics, and in both in physics and astrophysics, I'm always interested in what is in somebody else's plate. I can never just stay in what I am doing. So it has some advantages, but it's also a big defect. Anyway, so I accepted that responsibility and did it for 5 years. And at that point, but I had a lot of interest in the European Southern Observatory, ESO, which is an intergovernmental organization that does astronomy for the European countries, for a number of European countries, member countries, and has telescopes in Chile, and in particular the very famous, very large telescope in Paranal, which is now, has been for quite some time, the world-leading optical telescope in the world. At the time, it was just getting finished, and I got a phone call, a surprise, to see whether I would be interested in applying to be Director General. I applied and was selected, and therefore was Director General of ESO between 1999 and 2007. And in that time, not only did we finish VLT and its instruments, but I started ESO on a path to construct very large array of radio telescopes, so back to radio telescopes, but working at the highest frequencies in radio, which with a very small wavelength, sub-millimeter and millimeter wavelength range. And this is called ALMA, and it's an international project that was constructed in Chile also at a height of 5,000 meters, because we needed a very dry sky above us to do these observations, because otherwise the water in the atmosphere would prevent the very delicate observations ALMA wants to do. And it's been done in collaboration between Europe, the United States and Canada, and Japan, and of course in Chile, so Chile participation. And it's at the moment an extremely successful also ground instrument. So at ESO, we wanted to do an extremely large telescope. And I launched the study of a completely novel concept for such a telescope, using 5 mirrors instead of the usual 3, and correcting already for the problems due to the atmosphere. And was fortunate enough that I convinced the community that this was the thing to build, and I convinced the ESO Council and launched the studies of the extremely large telescope, which ESO is now constructing with a diameter of 39 meters. And it will be in Chile, very close to the VLT. So that was the time when I decided to quit. Actually, I could have stayed another 2 years, but I thought 8 years was enough, and came back to France. I was doing that from Germany and Chile, thinking, well, this time I'll just go under my tent. And I did one other important thing in that period, which I think will interest you, because another surprising phone call I got was from the previous president of the International Astronomical Union, asking me whether I would be interested in becoming the president of the International Astronomical Union. So there also I said yes, and I was elected president, and was president from 2006 to 2009. So 2006 is just when we had the big Pluto incident. So I started with that. But more interestingly, 2009 was the International Year of Astronomy. So I was, at the helm of this International Year of Astronomy, first to obtain the approval from the United Nations for it to be named International Year of Astronomy. And then 2009 was a year where millions of people all over the world were presented with the results of astronomy and approaches to astronomy and interested in astronomy. And I think that really has been very successful and very interesting. As a result of this, we decided to create in the IAU Office for Development and involve much more, use astronomy for development. And several countries made proposals to host that, but South Africa was selected. And Kevin Govender became, and still is, the Director of Astronomy Development in South Africa, which by now has made little children all over the world. So it's a net of centers, but the principal one is in South Africa. And this is not only interesting the people into astronomy, but trying to get useful skills through astronomy for many other endeavors in life. So I think that's something I'm really proud of, I must say.
Absolutely.
Yeah.
And then one day, another surprising phone call from the French Prime Minister.
You must have been getting used to it by then.
No, the truth is, no. Every time it was a surprise. This was, by that time, I was already 65 years old. And in France, age limits are quite serious. So when I had come back to France, they wanted me to be director of this and that. They offered me all the top jobs in research, but they all had an age limit, which I had passed. So, I said, but don't you see? Anyway, so here I got a phone call and I said, well, now we found a job that doesn't have an age limit. So can you please take it? And this was to be High Commissioner for Atomic Energy. It's a very strange position. In the French Atomic Energy Commission has like a double head. The general administrator, who is like the director general, and you have the High Commissioner, who is a little bit like a president, mainly having important decisions on orientations and strategy and this sort of thing, and is at the same time an advisor to the French government. It's a job really within the French government. So anyway, I did that for 3 years, got very interested in particular, not only in nuclear energy, but in alternative energies. And during that time, the CEA, the Commissariat à l'Énergie Atomique, became also alternative energy and atomic energy. So it's involved in those two, and of course continuing to do a lot of many other things, and in particular basic research. So astrophysics in particular is very, very strong these days in this organization, I'm proud to say. So I did that for 3 years, and then after that, yes, I retired under my tent, although I had all kind of interesting committees to chair, in particular for space, related to space. And then one day, another surprising phone call.
We knew that was coming.
Yes, very surprising, I must say, from somebody I didn't know, who was the vice president of the board of the SKA organization. And of course, I knew all about SKA, who asked me whether I would be interested in becoming the chair of the board of the SKA organization. I accepted that as well. And in a few years, we managed to go to the next stage, which is the SKA Observatory, where we are now. And I thought that would be the time for me to leave. But they asked me to remain also as chair of the council. So at the moment, I'm chair of the council of SKA. Anyway, that's a long story.
Which brings us today. I mean, what a story.
Is that all? Wow. So you've worked, across the entire electromagnetic spectrum, from the high energies and X-rays to the, infrared. It was IRAS, I'm assuming, the telescope, the satellite that you helped launch, right?
No, IRAS.
Right.
IRAS was previous to ISO. IRAS was indeed the first infrared satellite, but it didn't have instruments. It was scanning the whole sky, and it made a map of the whole sky.
Right.
At a certain sensitivity. And you could not, like you do normally in astronomy, you want to study something, you sit on it and stay as long as you need to get all you want to know about the subject. That's what an observatory does. IRAS could not do that. It was just going through the sky. So IRAS, of course, made a huge number of discoveries, but then one wanted to go back to some of these IRAS sources and know more about it, and in general, be more sensitive. And for this, you need an observatory which can point and stay on a source. So the first observatory was Infrared Space Observatory, launched in 1995 by the European Space Agency, and that's where I worked.
Right, so that's ISO, great. And then you obviously facilitated ALMA in Chile, the ELT coming up, and now working on the SKA. What an incredible career. And you worked on theoretical astrophysics, and you just built a radio telescope from scratch before your PhD.
The first one, I must say, because I am not a hands-on person, and so in the telescope in Argentina, I did the most menial jobs you can think of. For instance,
as a student,
it had to be painted not to become rusted. and it was very big. And at the time, since I had no vertigo, I did that. I spent a few weeks of my life sitting there up, painting. So you see, very, very intellectual tasks.
Oh, I understand, Catherine. I'm also very much not a practical person. And I helped to build the LOFAR telescope. But actually all I did was stick the barcode labels on each of the antennas.
That's very important.
It's an important job.
Exactly. So that's the sort of thing I did. I also bought all the furniture for the buildings that we had. And we received enormous boxes full of screws. And we spent weeks separating them in sizes. So very, very highly intellectual job.
Just before we go, Catherine, you've had such an amazing career doing so many different things, being involved with so many different people. You must have a whole lot of experience that the next generation can really benefit from. Do you have any final messages for listeners, and particular maybe young people who are interested in following careers in astronomy or astronomy adjacent fields?
Yes, my message would be, I open my arms and come, children, come to astronomy. Come to astronomy. It opens the door to inspiration. It opens the door to interest, to living above material contingencies and political contingencies, and opening your mind. It really blows your mind, actually, blows your mind. And at the same time, you can acquire skills that can be useful in many other avenues. So you can stay with it a few years and then go and do other things if you want. But you are certain to profit from it. The other thing I want to say is that the life of astronomers is changing all the time. And the life of astronomers today has nothing to do with what I have seen 20 years ago, 40 years ago, or before, because I have now been in the trade for quite a long time. I recently celebrated my 50 years after my PhD. So,
oh, congratulations.
And it will continue changing. So if you get into astronomy, it's not that, well, so now I've made this step and the rest of my life I will be doing this. No, you get into a life, as I mentioned in my case, full of surprises. I think for every astronomer, the life is full of surprises and therefore interesting.
Absolutely. I mean, mine's already been full of surprises. I'm scared. I'm scared as to what might be coming next. Catherine, it's been an absolute pleasure chatting to you. Your career and your experience and what you've been engaged in over the last 50 years in astronomy is really mind-blowing. Thank you for sharing your time with us and sharing some of that. I think we could have talked for many more hours, or maybe if you write your life story, that would be nice.
Yes.
If you can find some time. But really, we really appreciate your time, and congratulations. I know you've only been involved for 5 years, but congratulations on the SKA groundbreaking. Your humility is too much.
Yeah, and thank you very much for your service to the astronomy community in so many different ways, and your service essentially to humanity and our collective understanding of our existence, which is, there's nothing bigger than that, I think. So thank you very much, and thank you for inspiring generations of people, and here's to the future.
Well, and thank you very much for your interest, and it was very pleasant.
Wonderful. Thank you so much, Catherine.
All right. I mean, excitement abounds, doesn't it? So hopefully at the moment while you're listening to this, we're on separate flights to the sites in Australia and South Africa where the ceremonies are taking place. There's going to be a live link between the two sites. So very exciting. And, just wonderful to hear from Catherine about her life, about the SKA, about everything it's going to achieve. And, as I said to her, I'd love to read her life story. Wow, she's seen a lot.
Oh, gosh.
And been involved in just so much. Like she's,
I know.
Over the last 50 years, has been like a golden era for astronomy.
Yeah.
And it seems like she's been driving it.
Yeah, I know. She's so inspirational and also so approachable, which I think is amazing. I'm kind of about as awestruck as I was when we spoke to Dr. Bernie Fanaroff, and you remember how much I
Absolutely,
was excited about that.
He was also just an incredible character and,
Yeah.
Just contributed so much to the field. It's just wonderful to have the opportunity to speak to individuals like this, and I think we're very fortunate.
Exactly, and to share it with all of you. So hopefully you've enjoyed this episode, and hopefully we can bring you another one. The next one will hopefully be about the audio that we record from the actual commencement ceremony. I'm very excited I'm going to say hopefully about 100 times here, to hopefully be able to see the site where the telescopes are, and for you to see them in South Africa, Dan, and we'll take lots of photos. And I'm curious, are you going to take a cake on your flight?
Absolutely.
For your birthday?
Oh, absolutely. I'm going to take a cake, and on the way home we can celebrate my birthday with cake on a plane.
Cake on a plane.
Cake on a plane. I'll see if I can get the Minister of Science and Innovation to sing happy birthday to me. That'll be...
Please record it if
I'll
you do.
definitely record it. All right.
Okay.
So thank you again, as Jacinta said, for joining us. We hope you'll join us again for the next episode of The Cosmic Savannah.
In the meantime, you can visit our website, thecosmicsavannah.com, where we'll have the transcripts, the links, the pictures, and a lot of other stuff related to today's episode.
As always, you can follow us on Twitter, Facebook, and Instagram at Cosmic Savannah. That's Savannah spelled Savannah. And you can also find us on YouTube, where audio-only episodes are uploaded with closed captions, which can be auto-translated into many different languages, including Afrikaans, isiXhosa, and isiZulu.
Special thanks today to Dr Catherine Cesarsky for speaking with us.
Thanks to our social media manager, Sumari Hatting, and our audio editor, Jacob Fan.
Also to Mark Allnut for music production, Michal Werchek for photography, Carl Jones for astrophotography, Susie Karras for graphic design, and Justine Crook-Manzor and Maloko Makweja for transcription.
We gratefully acknowledge support from the South African National Research Foundation, the South African Agency for Science and Technology Advancement, the South African Astronomical Observatory, and the University of Cape Town Astronomy Department.
You can subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts, and we'd really appreciate it if you can rate and review us and recommend us to a friend.
And we'll speak to you next time on The Cosmic Savannah.